This problem is about the 150 houses in a certain development. We're told that some of them have air conditioning, some of them have a sun porch, and some of them have a pool. This is what we call an overlapping sets problem, and it's a bit unusual on the GMAT because it has 3 categories, air conditioning, sun, and pool, whereas normally these problems have just 2 categories. When they have just 2 categories, it's a better idea to make a table like this. This is a contingency table, and the nice thing about a contingency table is that it has all these boxes in which you can fit the given information. Unfortunately, a contingency table doesn't work when you have 3 categories, so for this problem, we're just going to have to stick with the Venn diagram. Now let's work through the problem and process the given information. We're told that there are 150 houses, so we can write total 150. This total represents the whole universe of the problem, everything in this box. Next, we're told that 60% of the houses have air conditioning, 50% have a sun porch, and 30% have a pool. Then we're told that 5 of the houses have all 3 of these amenities. Houses with all 3 amenities belong to all 3 circles simultaneously. In other words, they're right here in this area of total overlap. Let me color this in to make that a little clearer. The houses that have triple amenities, air, sun, and pool, are the ones in this red region. Let's write that down on the side here and say triples 5. That's 5 houses in the red region. Then we're told that 5 houses have no amenities. So those are the houses in this white space. They don't belong to any of the circles. Those houses are the nones because they have no amenities. And let's write that here. Nones, 5 houses. And finally, we're asked how many of these houses have exactly 2 of these amenities. So we can write question, how many are doubles? Doubles means that they have 2 amenities. And in terms of our color scheme here, the doubles are the houses in these green regions. In this green region, the houses have air and sun. In this one, they have pool and sun. And in this one, they have pool and air. The ones in the red region in the middle don't count as doubles because they have all 3 amenities. To solve this, let's create an equation that relates all these various quantities. So in the development, we have houses with air conditioning, and houses with a sun porch, and houses with a pool. And let's not forget about the houses that have no amenities, the ones that we called the nones. Now, adding all of that up includes every single house in the development, so you might think it just equals the total. However, the problem with that is that some houses, the ones that are red and green on the diagram, get counted 2 or even 3 times when you add up air, sun, and pool. We'll have to make an adjustment to the right side to take account of that. Well, if the problem is that the total only features the doubles once, we can just add the doubles a second time to the right side of the equation. And now, both sides of the equation are going to feature the doubles twice. We can make the same kind of adjustment to take account of the triples. The triples are showing up 3 times on the left side of the equation, right? Each triple house gets counted once as part of the air, once as part of the sun, once as part of the pool group. And to make sure that the triples get counted 3 times on the right side of the equation, we just add 2 more iterations of the triples. Now the triples are showing up on the right side once as part of the total, and then 2 more times here because we just added them in. Now we're ready to substitute in some values for the various words in this equation. For air, sun, and pool, we're given the percentages, so let's write that down using decimal notation. Air, we're told, is 60% of the total, so we can write 0.6, and that's going to be 0.6 times the total of 150. But let's process sun and pool also. So we have 0.6 plus, for the sun, it's 50%, so that's 0.5. And the pool is 30%, so that's 0.3. All of these coefficients, we said we were going to multiply by the total, which is 150 houses. Then for the nuns, we're told that there are 5 houses. So that's it for the left side. The right side, we know that the total is 150 houses. The doubles is the number we're trying to find, so let's just leave that as it is. The triples, that figure is given as 5, so triples is 5. And now we can manipulate this to solve for the number of doubles. So here on the left we have 0.6 plus 0.5 plus 0.3. That's going to add up to 1.4 times the 150 that we have. That's the total. And then we still have plus 5 equals, on the right side, we still have our 150 plus the doubles, plus it's going to be 2 times 5, which is 10. And now notice that we have 150 on both sides of the equation. So subtracting this 150 from the 1.4 times 150, we get 0.4 times 150. And then we have a 5 here and a 10 there. So subtracting the 10 from the 5, we get minus 5 here. All of that equals the doubles. And now we've come to the very last line. On the left we have 0.4 times 150, which is 60, and 60 minus 5 is 55. That equals the doubles on the right side. So the number of houses with 2 amenities is 55. Let me clean up my handwriting for you. And also, before leaving this problem, I'd like to mention a couple of takeaways. One of them is that it's a good idea to invest time on setup. By that I mean going through the given information and writing it down here, also jotting down the question. You might worry about spending so much time on preliminaries, but you can see that in this problem, half the battle is figuring out what the given information is saying, what the question is really asking. And here that's what enabled us to come up with this equation and then to have values sort of ready at hand that we could substitute into the equation. A second takeaway is that it's a good idea to limit the number of variables. It's tempting to rush about giving every single thing a name, like this: A, B, C, D, E, F, G, H. But the problem with this is that it can be hard to remember what all of these letters mean. Now, it's true you could pick the letters in a way that helps you remember, like if you choose S for sun because the word sun starts with an S, but even that isn't foolproof because sometimes you have 2 things that start with T, so if you call total T, then you're stuck trying to find something else for triples. It's better to just use words in your equation the way I've set it up here, because you're never going to be guessing what total means or what sun means. The other reason to limit the number of variables is deeper. It's that not every quantity deserves to be given any kind of name, because not every quantity matters. Think about what this question is asking. They're asking us how many of the houses are doubles. And notice that doubles, for the purposes of this question, are thought of as one entity. So if you go and assign a separate variable name to B, D, and F here, you're doing something that's quite pointless. All we care about is doubles as one group. And that's all for this problem. Do come back and look for more solutions from Chiron GMAT.